Hello, this is the fourth film about solutions. It's to do with dilution problems, and hopefully by the end of it you will know how the concentration of a solution can change if you add or remove solvent, and you'll have seen a couple of example calculations of these types of problem. Okay, why do we bother doing these kind of problems? Well, because in chemistry we're in all sorts of different situations we're diluting things. Here we've got an example where we're starting off with a particular concentration of glucose solution. We want to end up with a different concentration, so we need to know how much water we're going to have to add. Okay, here we've got a diagram of a standard solution being made. This is really, really important in year 12 in particular when you do titrations. And in these situations you add water to a volumetric flask, so you know how much water you're adding, and you need to be able to figure out what the concentration of your solution is. So you're going to use that in subsequent experiments. So lots of examples of where these calculations are useful. A really good formula to be able to remember is this one, C1V1 equals C2V2, but much more important than just being able to remember it is being able to rearrange it and to understand, most importantly I suppose, what these symbols actually mean. So if we look at this picture of some chap who's he's making himself some orange juice, starting with a concentrate, we can hopefully understand what these symbols mean in this context, right? Here is our original solution, this concentrate, so we know its original concentration is going to be C1, so C1 is the original concentration. How much of it do we have to start with? That's V1. Okay, how much do we end up with? That's V2. This 4 cans is how much we end up with. Okay, so V2 is the final volume, V1 is the initial volume, and this solution here will have a different concentration to the original one because we've diluted it, and that's going to be C2. That's our new concentration. Now, we should be able to rearrange this formula to find C2, so C2 equals C1 V1 over V2. I've just divided both sides by V2. I don't know what C1 is here in this particular problem, but I can put some numbers in and say that that equals V1, which is 1 can, divided by V2, which is 4 cans. That should be multiplied by a sign, shouldn't it? Right, so C2 equals C1 times a quarter. So in other words, our new concentration is a quarter of our original concentration. Okay. So moving on to a couple of example calculations where we're going to use this formula. Remember, it's important to be able to rearrange it and know what the symbols refer to in the question. So let's have a look here. Right, we've got a new concentration we're being asked to find. So that is, remember, C2. Okay. Another way of asking this question would have been to say, what's the molarity of the new solution? So look out for that. Okay. If enough water is added, we're adding water, we're diluting something, that's a good sign that you've got a dilution problem you're going to need to use this formula. 100 mils is our original volume, and 0.25 is our original concentration. We're taking this solution, we're making it up to 1.5 litres, so here's our new volume, V2. We're being asked to find C2. Okay, C2 equals, remember, C1V1 over V2. We just divide both sides by V2. Okay, put some numbers in here. C1 is 0.25 moles per litre. V1 was 0.1 of a litre. 100 mils, because there's 1,000 mils in a litre, divided by V2, which is 1.5. Okay, and that equals 0.025 divided by 1.5, and that equals 0.017 or 0.016 recurring, but 0.017 will do for our purposes, moles per litre. Okay, that's our new concentration, that's what we were asked to find. Okay, so there's one example problem. Here's another. This time we're not being asked to find the concentration, we're being asked to find a volume. The volume to which this must be diluted. So in other words, this is our new volume, V2. Okay, we're starting off with 500 mils, that's our original volume, and we're starting with a solution that has this concentration, so there's C1. Here's our new concentration, C2. What are we being asked to find again? That's V2. V2 is here. Divide both sides by C2. We've got C1, V1 over C2. What's C1? 0.02. What's V1? There it is, 0.5 litres, remember? Divided by C2, which is 0.001. So that equals 0.01 over 0.001, and you can see that that's 10 times bigger than that, so this equals 10. So our new volume is going to have to be 10 litres. Alright? Sometimes we get asked how much water you've got to add. Well, if we were trying to find that, we need to remember that we started with 500 millilitres, so the water that we added would be 10 litres minus 0.5 litres, and that's obviously 9.5 litres. Okay, so a couple of example calculations there, a formula to remember. Make sure you can rearrange the formula. If these problems are hard by the time you're practicing them for a while, then you probably maybe need to get a little bit of help with them, because if they're hard by the time you get to a test, then you're probably not ready to answer them in a test. Right, so come and get some help, do some practice, and once you think you're good at them, move on to the film about precipitation reactions. That's the last one in this series about solutions.